Hey guys, this is Mr. Grice for Algebra 2 Semester 2 Practice Final 2014 video number 2. Now we've already gone through the first 5 problems, and let's pick it up with number 6. Now, number 6 is asking what is the degree of the polynomial? So when we're finding the degree, I'm going to go to each one of these and I'm going to add up the exponents. So that first degree is 5. Add them up. Remember that y, if there's nothing there, there's a 1. So that's a degree of 5. So far my degree is 5. And then the last one, 3 plus 3, 3 plus 3 is, yeah, it's 6. So for this guy, our degree is 6. All right, number 7. Number 7, we have to multiply. So we need to make sure that we distribute everything that's outside. Okay, so what's negative 8 times negative 3? Well, that's positive 24. And then we add the exponent. So 2 plus 7 is 9. Negative 8 times positive 2 gives us negative 16. And once again, we add the exponent. So that's a 6. All right, and then negative 8 times negative 6 gives us a positive 48. And then we add the exponents. 2 plus 3 is 5. Okay, number 8. We're multiplying again, but we have to make sure to pay attention to that exponent. That means 3w minus 7 times 3w minus 7. Okay, and to solve this, we have to distribute. 3 times 3 gives us 9, w squared. 3w times negative 7 gives us negative 21w. Negative 7 times 3 gives us negative 21w. And then negative 7 times negative 7 gives us a positive 49. Okay, now when we combine our like terms, those don't cancel, guys, just because they're both negatives. Okay, they're the same sign, so we add them and we get 42w plus 49. All right, number 9 says to factor. So when we're factoring, the first thing we check is there a GCF? And there isn't. There's no GCF. So I need to multiply a times c, which gives me a positive 16. And I want numbers that add up to give me a negative 8. That's my number in the middle. So what numbers is that? If you can't think of it off the top of your head, off to the side, what are the numbers that multiply to 16? 1 and 16, 2 and 8, 4 and 4. And the only set that gives us 8 is 4. And that's supposed to be a negative 8, Mr. Grice. Okay, so for that to be a negative 8, I need both of those to be negative 4s. And it works. And guess what? It works on the top too, which is exactly what we needed. Okay, now we can do this 2 separate ways. We can go straight to our answer, but I'm going to show you splitting the middle term. Okay, but we get m squared minus 4mn minus 4mn plus 16n squared. So what's the GCF of the first group? Yeah, the only thing that they both have in common is an m. And then we're left with m minus 4n. Well, what about the back group? The back group, I can take out a -4, and then the variable they have both in common is an n, so -4n, and then we're left with m minus 4n, which is great because those match up like they're supposed to. So then our answer is the m minus 4n, the binomial that was the same, and then the m minus 4n, which was the GCF. Okay? All right. Number 10. So number 10 says to write an expression that applies the Pythagorean theorem to the triangle below. Well, what's the Pythagorean theorem? The Pythagorean theorem states that a squared plus b squared equals c squared. The only thing we care about is c. C is the hypotenuse, and the hypotenuse is directly opposite of the right angle. Okay? Now, the other two terms don't matter. So I'm just going to write the 2x first. So we have 2x squared plus x minus 3 squared equals 4x plus 1 squared. Now, all it said was to write the expression. It didn't mean we had to solve it. And guys, just so you can see, there's the ax squared plus bx, or a squared plus b squared equals c squared. Okay, so we're doing the same thing. All right, let's flip it over. Now we've got some multiple choice. This is not where you just get to, oh, I'm just going to circle it because it's multiple choice. No, come on, show your work. So number 11 says the ordered pair -3 and 2/5 is a solution to which of the following systems? Well, what that means is we have to plug it in. And if it doesn't work, then I know I don't have to check the rest of it. So let's check with the first one. -3, or -9 times -3 plus 5 times 2/5. Does that equal 39? Well, the first part, -9 times -3 gives us -27, or positive 27. 5 times 2 is 10. 10 plus 5, or 10 divided by 5, is 2. And does that equal 39? Well, no, it equals 29. And since 29 doesn't equal 39, I know that A is not my answer. Okay, now, why don't you guys try the same thing with B? Go ahead and pause the video, and good luck. Okay, so I ended up getting -23 equals 23, and is that true? No. Okay, so B doesn't work either. So hopefully C is the right answer, but let's double check. Now, if you notice that equation, 9x plus 10y equals -23, isn't that what we just did on the other one? The exact same? And we got -23 equals -23, so we're good. I'm not going to do all that work again. I've already done it. Let's look at the next one. So we have -3 times -3 minus 5 times 2/5. Does that equal 7? Well, -3 times -3 is a positive 9. 5 times 2 is 10. 10 divided by 5 is 2, and that's a -2. And 9 minus 2, that equals 7. So C is our correct answer. All right, number 12. Number 12 says to match the graph with the correct number of solutions, and not all choices will be used. So let's see. Oh, it doesn't have, oh, these are supposed to be lines, so we're supposed to have lines right here. I knew it looked a little funny. All right, so I'm going to start with no real solution. Do any of those graphs show no real solution? Well, I know that our middle one has a solution because they meet. But it's either when the lines are on top of each other or the lines don't touch. I don't know which one. Well, wouldn't no real solution means that the lines never intersect and don't touch each other? Yeah. So our no real solution is that last one. Okay. B, one real solution. We just talked about one real solution is where your graphs meet at one exact point. So B goes in the middle. So we did A, we did B. Two real solutions or infinitely many real solutions. Well, I know that infinite solutions is when it's the same exact line. And doesn't that look like what number 12 is? Yeah. Okay. So for 12, the last one is D, infinitely many solutions. Okay. I'm going to go ahead and stop the video again right here, just because I don't want this to get too long. But if you have any questions, please talk to Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 2 Semester 2 Practice Final, video number 2. Thanks for watching.